आया ये हम जरा देखने की कोशिश करते हैं। So let's go for one particular experiment. And what is this experiment? And we are performing a collision problem, है ना? So collision problem, simple elastic collision you can assume. So there is a frame A, and suppose this is a train and there is a platform. Your train and platform is the best thing to understand. And this train is moving with velocity v, and this is moving with velocity v. There is a person observer, one observer is here, and let's say another observer is here. And on the train, there is going to a collision problem is taking place. So there is two particle. Let's say this is my M1, this is my M2, and we have basically, let's say, U1 and U2 is the velocity with respect to train. So, and you can just take any direction. So with respect to train, its initial velocity is U1 and U2 of mass M1 and M2. And after the collision, what is going to happen? Its velocity is V1 and V2. So with respect to train, when we are seeing this thing with respect to train, then what we have? Conclusion. The conclusion is very simple. There is conservation of linear momentum, and this is law of nature, because if there are elastic collision, the linear momentum must be conserved. So you can just assume that M1 U1 plus M2 U2 must be equal to M1 V1 plus M2 V2. And this is with respect to, let's say, this is person X and this is person Y. So this all thing is given with respect to person X. So with respect to person X. So you can also write this whole thing if we are talking about the reference frame in a reference frame term. So we can write M1 U1 with respect to X plus M2 U2 with respect to X must be equal to M1 V1 with respect to X plus you can go for M2 V2 with respect to X. So now this is our situation. Okay. But if this person is going to measure this particular thing by using the fact that this V is moving with some relativistic velocity, and if this U1, U2 and V1, V2 is also relativistic in nature, then what should be the final answer? There must be again conservation of linear momentum.
Yes.
Because the frame is just inertial frame, and from the inertial frame there must be law of nature must preserve. लॉ ऑफ नेचर क्या होना चाहिए? हमेशा प्रिजर्व होना चाहिए. बट दिस इज नॉट गोइंग टू हैपन. This is not going to happen. What is going? So what we expect M1 U1 with respect to Y must be equal to M2 U2 with respect to Y must be equal to M1 V1 with respect to Y plus M2 V2 with respect to Y. So ये होना चाहिए, but this is not going to happen. So if this is not going to happen, then obviously we have to think in a very different way. Are you getting my point? यानी कहीं ना कहीं हमें फिर से चीजों को करेक्ट करने की जरूरत है. अभी तक हम लोगों ने क्या क्या करेक्ट कर लिया था? Mainly we have just seen the fundamental thing. What is fundamental thing? Length and time. So we have done some correction in length, we have done some correction in time. But yes, you can see here the mass is also very fundamental thing. Mass भी आपके लिए क्या है? बिल्कुल ही वैसा ही fundamental है. And here Einstein come into picture and he give the mind-blowing idea. Actually, this thing is very different, but मैं आपको just explain करने के लिए बता रहा हूं कि that एक फ्रेम से कंजर्वेशन ऑफ मोमेंटम हो रहा है तो दूसरे फ्रेम से भी कंजर्वेशन ऑफ मोमेंटम होना चाहिए, but it is not going to happen. So if it is not going to happen, then why it is not going to happen? This is very important thing. And then Einstein gave the concept of relativistic mass. So before relativistic mass, what is his idea? Einstein just say that any mass can be equivalently converted to the energy and any energy can be equivalently converted to the mass. This is his mind-blowing idea. And what he says, suppose if any particle has mass m and then equivalent energy is something like mc square. And he also says, but he first give the whole thing in term of rest mass. So let's try to define what is rest mass, and then we will try to define what is rest mass energy, and then we will see what is going to happen when particle is going to move with respect to observer. Okay, so let's try to understand what is your rest mass energy or rest mass. So if mass is rest with respect to observer, or if relative speed between mass and observer is 0, then observer will measure rest mass. So rest mass in general we are defining by m naught. So if the mass is at rest, you can define it by m naught. The equivalent energy according to Einstein is rest mass energy. And what will be that energy? The rest mass energy is equivalent to, according to Einstein, is m naught into c square. What is c? C is nothing but the speed of light. So m naught c square is rest mass energy. So this is one of the very interesting argument that if you have 1 kg of mass and how much energy, and if it is rest with respect to you, then you can extract that the energy is 1 kg into c square. So this is mind-blowing idea. Now just you can tell me and look at how this thing can be easily understood by the common sense. Suppose this mass is going to move with respect to you, then you will extract more energy or less energy than this. Just try to think in terms of energy. Suppose if anything is going to move, suppose his rest mass is m naught, and minimum energy you can take is m naught c square, and if this particle is going to move, then which type of energy you have due to motion of particle?
Kinetic energy.
Kinetic energy. And kinetic energy is always positive in nature.
Yes.
Yes, sir.
Yes. So the energy which you can equivalently write will be more than m naught c square, isn't it?
Yes, sir.
Because total energy, if particle is going to move, then total energy E can be written as m naught c square, which is rest mass energy, plus kinetic energy. And here this kinetic energy is not equivalent to half mv square. Please mind it. Kinetic energy, it's something positive energy. I am going to accept this one. And we will also try to figure it out. What is this kinetic energy? So now you can see this energy.
Sir,
हाँ बताओ.
if kinetic energy is not half mv square,
Hmm.
then it is a function of mass and velocity.
Then it is function of.
तो मतलब then it is product of mass and velocity. मतलब यदि वो half mv square नहीं है,
हाँ
वो mass और velocity का ही product होगा.
हाँ होगा, बिल्कुल होगा. But that is not half mv square. Okay.
Okay, sir. Understand.
हाँ अभी देखो, अभी दिखाते हैं, अभी देख रहे हैं हम लोग. पहले चीजों को समझने की कोशिश करो. Then what is this particular thing? Now you can easily see that this E will be greater than m naught c square. आप यहां पर एग्री कर रहे हो या नहीं?
Agreed.
है ना? So this E is greater than m naught c square, and this E is nothing but the total energy of a particle. Are you getting my point? This E is nothing but total energy. And now according to Einstein, this energy can be also written in term of mass. आइंस्टाइन ने क्या कहा? आइंस्टाइन ने कहा कि किसी भी एनर्जी को आप मास के इक्विवेलेंट लिख सकते हो, एंड यू कैन राइट एनी मास एज अ फंक्शन ऑफ एनर्जी. So what Einstein has said, and Einstein have told us that now this is total energy, and this total energy is equivalent to m into c square. And what is this m? This m is identified as relativistic mass. And this relativistic mass, what is relativistic mass? When particle is moving with respect to observer, then observer will measure the relativistic mass. Then observer will measure relativistic mass. And now from here, and that relativistic mass you can denote with m. And now the total energy is nothing but relativistic mass into c square. अब यहां पर देखो कितनी मजेदार बात हो रही है, और आप इसे now you can see I can write this E as equal to mc square, which is greater than m naught c square, and this c square can be cancel out. So this m can be greater than m naught, isn't it?
Yes,
So
sir.
this is the same kind of thing where time dilation is going to happen, isn't it?
Yes, sir.
है ना? And Einstein proved this thing. Einstein ने prove किया, और आप believe नहीं करोगे, this proof is with the help of time dilation. ये जो proof किया गया था, that is the help of time dilation. And what is this m? The relativistic mass m can be identified as m naught root under 1 minus v square upon c square. And what is v? V is the relative speed between observer and mass whose rest mass is m naught. So you can see this will be your relativistic mass. And now I can also give the definition of kinetic energy now. So what is the definition of kinetic energy here? So E I can write as mc square is equal to m naught c square plus t, and this m can be written as m naught c square root under 1 minus v square c square is equal to m naught c square plus t. And what is your t? This t is basically m naught c square root under 1 minus v square c square minus m naught c square. And this is my new definition of kinetic energy. Are you people going to understand this thing? Now, let's see. If V upon C tends to 0, then this kinetic energy must be equivalent to half mv square. Galilean के फॉर्म में आना चाहिए, है ना?
Yes, sir.
So let's try to prove this thing. Let's try to check it कि ये हो पा रहा है या नहीं, ताकि आपको कॉन्फिडेंस हो कि हमने जो किया है that is not a any absurd thing which is very logical. So let's try to go for this. So this kinetic energy I can write as m naught c square. I can take it common, and here 1 by, or you can just write 1 minus v square c square to the power minus half minus 1. And we can just go for the Taylor expansion because v square c square is very small. So this t is equal to m naught c square, and here is 1 plus 1 by 2 v square upon c square. And now we can neglect higher order term. Minus 1 is also there. This one is cancel. This c square is cancel. And this t is nothing but half m naught v square, which is nothing but kinetic energy of the Galilean. Isn't it?
Yes.
आप देख पा रहे हो? If you have any
Yes,
question,
sir.
you can ask right now.
Sir,
Hmm.
we are saying it as mass and energy. Mass and energy means mass can be converted into energy. Energy can be converted into mass.
Hmm.
But actually, there is E into mass into C square is there. Na? It is not like that energy is converted into mass. There is a how it is.
Yes, you can write the, if you have any mass. Obviously, you have to make it the dimensional thing, na? So, what will be equivalent energy for that mass? I just want to ask one question to you, and this is very interesting question. Just let me ask you. You have 1 joule of energy. Can you, what is equivalent mass of that?
One kg.
You have 1 joule of energy. Then
1
what
kg.
will be equivalent mass of that?
1 kg.
By c square.
Yes.
1 joule. If you have energy of unit of 1 joule energy you have, so how many mass you can have? Equivalent mass. Then this E upon c square is your mass. Something like this. So we are using this concept, isn't it?
Yes.
Okay.
Are you getting my point? So whenever you are multiplying any mass with a c square, it is equivalent to some energy. And you can say that this energy is equivalent to this mass actually. because C is always constant for everything, है ना?
Okay, sir.
Okay, so and this is mind blowing thing. और आप believe नहीं, and you can easily see this all this thing that in whole radioactive activity calculation, when you are calculating the mass defect, what is mass defect? You are calculating this mass defect in term of energy, isn't it? याद है कुछ न्यूक्लियर फिजिक्स में? क्लास 12 में किया होगा आपने.
Yes, sir. Delta m into c square we calculate.
डेल्टा m into c स्क्वायर कैलकुलेट करते थे.
Yes.
उसमें क्या डेल्टा m कैलकुलेट करते थे? नंबर ऑफ न्यूट्रॉन्स, नंबर ऑफ
जी.
प्रोटॉन्स माइनस एटॉमिक मास इनटू c स्क्वायर, isn't it?
Yes, sir.
एंड these all things, ये सब कहां से कॉन्सेप्ट आ गया? दैट यू आर, आप मास डिफेक्ट कैलकुलेट कर रहे हो बट इन टर्म ऑफ एनर्जी. दैट इज ऑल फ्रॉम दिस पर्टिकुलर रिलेटिविस्टिक एनर्जी. Are you getting this thing?
Sir.
Side हो जाएगी.
हेलो, हाँ.
Side please, sir.
It's okay.
Yes, sir.
Okay. So now this is now again we will go for this particular experiment. Now what is going to happen? That experiment of the collision, and you will see that initially we have m1 with respect to, now m1 u1 with respect to x plus m2 u2 with respect to x is equal to m1 v1 with respect to x plus m2 v2 with respect to x. Now this whole thing can be changed something like this. m1 with respect to x. Are you getting my point? And we are writing u1 with respect to x plus m2 with respect to x, u2 with respect to x is equal to m1 with respect to x, v1 with respect to x plus m2 with respect to x, v2 with respect to x. So this is with respect to x, and suppose this whole thing is going to write with respect to y, then how you will write this thing? Then your mass will also going to change. m1 with respect to y, u1 with respect to y plus m2 with respect to y and u2 with respect to y must be equal to m1 with respect to y, v1 with respect to y plus you have m2 with respect to y, v2 with respect to y, and then you can easily calculate the relativistic mass with respect to another frame. And now you can, when we have corrected this whole thing with this particular concept, then we have find there is conservation of energy, of momentum. So you can see this works actually, है ना? क्योंकि लॉ ऑफ नेचर क्या कहता है? लॉ ऑफ नेचर कहता है कि अगर एक कंजर्वेशन प्रिंसिपल एक इनर्शियल फ्रेम में है, then another conservation principle must be also into the another inertial frame. लेकिन ऐसा नहीं हो पा रहा था if we are assuming that mass is constant or mass is same for both frame. But when we are taking that mass is different from both the frame, and that mass is nothing but the relativistic mass, then this works and there is conservation of linear momentum, and it's validate that concept of relativistic mass of the Einstein. Everyone is comfortable?
सर आपने जो एक्सप्रेशन लिखा है ना उसमें से लास्ट टर्म जो है ना वो क्या है, मतलब समझ में नहीं आ रहा है।
लास्ट टर्म क्या है ये?
हाँ, उस एक्सप्रेशन में लास्ट टर्म m2
m2y v2y।
ओके।
मैं अब ये कह रहा हूं कि आप जिस भी ऑब्जर्वर के रेस्पेक्ट में देख रहे हो, सिर्फ वेलोसिटी ही उसके रेस्पेक्ट में नहीं चेंज करो, आप उसके रेस्पेक्ट में मास भी चेंज करो। आर यू गेटिंग माई पॉइंट?
यस यस।
आप उसके रेस्पेक्ट में मास भी चेंज करोगे, क्योंकि मास इज ऑल्सो डिपेंडेंट ऑन द what will be the relative speed between observer and that particular mass. So now you can see we have three fundamental things. First is mass, second is length, and third is time. And all three fundamental thing is going to change in the relativistic domain. Length is going to contracted, time is going to dilated, and moving mass is appeared to be what? Heavier. So this is the final statement by the relativistic mass, for the relativistic mass, that moving mass appeared heavier. Moving mass appeared heavier, isn't it? And you can easily use this concept, and also you have to same, if you have proper time, this proper time is nothing but unique in nature. Similarly, proper length is unique in nature, and similarly we have the rest mass is also unique in nature. So rest mass, only those observer will observe who is rest with respect to observer. Otherwise, if mass is moving with respect to you, and that mass is nothing but known as what? Relativistic mass. So we have new concept of relativistic mass is equal to m relativistic mass, and this will be m is equal to m naught root under 1 minus v square upon c square. And here we have relativistic energy. And what is this relativistic energy? Is equal to m c square, and that value is equal to m naught c square root under 1 minus v square upon c square. And similarly, we have kinetic energy. And what is your kinetic energy? The kinetic energy is E minus m naught c square. This is your three mass energy equivalent formula. And once mass is going to change, then obviously momentum is going to change. Your expression of force is going to change. Everything, every dynamical variable is going to change. And if we are going to plot m versus c, then what is going to plot? क्या होगा plot? Sorry, m versus v. Then at v is equal to c, we will start with some basically rest mass m naught. So this is my rest mass, and as it will go, it will be saturated, but it will never touch the C, and this will be C. But it will never touch the C. Why? Because we have one particular argument also, that any materialistic particle cannot achieve a speed of light. Everyone is comfortable?
Yes, sir.
Now look at the next part of this particular session. यहां तक कुछ पूछना है तो पूछ सकते हो. You can ask anything if you want. We will do problem, don't worry. But before that, let me complete the complete theory. Okay, so let's try to go for a relativistic momentum, and then we have one very interesting relationship between energy and momentum, and then we will try to different problems. Okay. Now, what is my momentum? My momentum is defined as m into v. Yes, this is definition of momentum. Now, what will be m now? This m is what? Rest mass or relativistic mass?
Relativistic.
Relativistic mass. So this momentum can be written as m naught v root under 1 minus v square upon c square. So this is definition of momentum. And if you want to go for the magnitude, then magnitude of this momentum is m naught v root under 1 minus v square upon c square. So this is magnitude. Okay. Now, this is your momentum, magnitude of momentum. And here is my energy. And energy is m naught c square root under 1 minus v square upon c square. है ना? So now from these two equations, we can replace v in term of momentum, and we can write that relationship between energy and momentum. लिख सकते हैं ना? v को हम लोग यहां से हटा करके we can write the relationship between energy and momentum. लिख सकते हैं या नहीं? Just divide this thing. What you will get? P by E is equal to m naught v upon m naught c square, and you can easily get value of v is equal to, so this m naught is cancel out, so value of v is equal to what?
PC square by
pc square by e, है ना? And now you can put this thing here and you can get the relationship between p versus e. मिल जाएगा relationship? Yes या no?
Yes, sir.
है ना? Just put it here and you can get the relationship between these two.
E square c square plus m naught square c to the power 4.
क्या हो गया? What will your relationship क्या आ रहा है? Have anybody have done this thing? और मैं करूं इसे? Just look at here.
E square plus p square.
E is equal to m naught c square root under 1 minus, ये क्या आ रहा है? p square c4 upon e square, है ना?
Sir,
हाँ,
सर
कुछ
A
गड़बड़?
equal to
p
node
square c square plus m naught square c to the power 4.
हाँ, क्या आ रहा है? p
p
square
square c square plus m naught square c to the power 4.
is equal to e square.
Yes, sir.
आ रहा है ये?
yes यार
Yes, sir.
Okay, good.
Sir,
So
actually,
now you have
root
this
three.
particular relationship. What is this relationship? So if you will solve it, you will get this one, and you have e square is equal to p square c square plus m naught square c to the power 4. Now, if you have this relationship, and this is one of the very fundamental relationship you can have. What is m naught c? What is this particular thing?
Rest mass.
Rest mass square.
Rest mass का whole square, है ना? And what is e square?
Energy.
Total energy.
Total
of-
energy.
Energy square. And what is pc square?
Kinetic energy.
Not kinetic energy square. Please. Why? Because your total energy, ये गलती कभी मत करना है ना. E is equal to kinetic energy plus m naught c square. अब दोनों तरफ स्क्वायर करो तो देखो क्या आएगा. E square is equal to t square plus 2t m naught c square plus m naught square c4. So now you can see what is p square c square. This is equivalent to this one, na?
Yes, sir.
Are you getting my point? So PC is not a kinetic energy. This is just a magnitude of momentum into speed of light. That's it. So P into C is magnitude of momentum into speed of light. Please always take care of this particular thing. बच्चे बहुत ही ज्यादा कंफ्यूज होते हैं कि this is kinetic energy square. So now you can equivalently write. So you can write this particular thing. P square C square is equivalent to kinetic energy square plus 2 times T and m naught C squares. So this is, and this is not any physical meaning. This is just one mathematical calculation. But now look at this particular thing. This is mind-blowing expression we can use into physics. Why? Because writing energy as a function of momentum is one of the modern way to calculate the different thing. And now look at what is going to happen and which type of symmetry you want to just see in this particular expression. So let's try to go for this particular expression. Now, if I am going to write PC in vertical axis and on horizontal axis I am writing m naught c square, then isn't it this is something like Pythagoras law? So what is this particular thing? This is nothing but E, है ना? This is something like Pythagoras law, isn't it?
Yes, sir.
पढ़े हो ना? H square is equal to B square plus P square. Yes? And this is something like your thing. And now you can analyze and you can give the mind-blowing idea. And what is this particular mind-blowing idea? You can see. Now, if P is going to 0, if momentum is going to 0, then your total energy is equivalent to what?
m naught square c to the power 4.
M naught C square, isn't it?
M naught c square.
Just simply m naught C square. Now, on another way, C cannot be go to 0. C is some constant. If I am saying my mass is going to 0, then what will happen to my energy?
P into c.
P into C. And you have a concept of momentum where particle has 0 mass, isn't it? Are you getting my point?
Yes.
You can
Like
give.
photon.
Huh? Yes.
Like photon.
For photons. For photons. Yes. So you can see E is equal to PC. And this P is equal to E upon C. And you can have momentum of a particle without having mass, which is mind-blowing idea. You have momentum of a particle without having mass. And here, what will be the source of this particular momentum if mass is not there? That is nothing but energy. And that energy will be actually dependent on mainly frequency, and we can give the concept of massless particle. So what is massless particle? The concept of massless particle, where rest mass of that particle is equal to 0, and then your momentum of a particle is equal to E upon C, and this E is nothing but h nu upon C. Are you getting my point? This E is nothing but h nu, and this is the concept of what? Photon. So we have a special type of particle. We have a special type of particle whose mass is equal to what? 0, but which has momentum. And what will be the speed of that particle?
Speed of light.
H nu.
What is the speed of that
C.
particle?
Speed of light.
Speed of light. So now you can make a theory. What is that theory? If any particle is moving with speed of light, or c, then it is assumed to be massless. And vice versa is also true. If particle is massless, it will move with the speed of light. Are you getting my point?
सर
हाँ.
पार्टिकल को इस रिलेटिविस्टिक मास होगा, ये अभी है तो मतलब
Sorry?
तभी इसको हमने देखा कि रेस्ट मास इसका 0 होगा, लेकिन रिलेटिविस्टिक मास होगा या फिर ये भी 0 होगा।
जब उसका रेस्ट मास से 0 है तो रिलेटिविस्टिक मास का तो कोई कॉन्सेप्ट ही नहीं हो गया ना.
हाँ हाँ,
दैट इज ओनली रिलेटिविस्टिक मास का कॉन्सेप्ट उसी के लिए कर सकते हो जिसका रेस्ट मास 0 नहीं है.
हाँ सर.
And so we are just discussing a very different type of particle which is moving with the speed of light, and it is massless. And photon, you have n number of theory which can be discussed, that photon is just behaving like a particle, isn't it? And that is nothing but the bundle of energy. That energy, it just try to acquire.
Wave packet.
And a wave packet, so jo bhi bolo, that is energy packet, not wave packet, energy packet. है ना? And it is basically moving with the speed of light very fast, and which is actually what? Massless in nature. But even if it is massless, it has momentum, isn't it?
Okay sir.
है ना? So you can have, if any particle is moving with the speed of light, then it is assumed to be massless. And similarly, if any particle which is massless, it is bound to move with what? Speed of light. So you can see the whole idea of classical mechanics is going to change when we are discussing this particular thing of mass energy equivalence. Okay, if you have any doubt, you can ask me.
सर अगर मास 0 होगा तो मोमेंटम इक्वल टू मास इनटू वेलोसिटी, वो इक्वेशन वैलिड
वो इक्वेशन नहीं वैलिड है. दैट इक्वेशन इज नॉट वैलिड.
ओके सर.
है ना? दैट इक्वेशन इज ओनली वैलिड फॉर अ पार्टिकल व्हिच हैज सम रेस्ट मास. ओके
ओके सर.
एंड हियर वहां पर आप m इंटू v से बायस्ड हो मोमेंटम को लेकर के, बट एक्चुअली व्हेन इट इज massless particle, then momentum is basically gained due to this particular energy, and that energy is not a function of mass actually, that is function of frequency.
ओके सर.
Okay, and
Okay.
this is your momentum of any photon, and you can easily write h nu upon c. ठीक है?
सर
हम्म
अगर हम लोग ये मासलेस पार्टिकल मतलब इसको कंसीडर ना करें और नॉर्मल पार्टिकल को कंसीडर करें
हम्म
और उसको फिर स्पीड ऑफ लाइट में ले जाए
हम्म
फिर मास इन्फिनिटी हो जाए मतलब
हाँ, तो फिर आपने फिर एजम्पशन को ही तो अवॉइड कर दिया ना। आपने ये एजम्पशन रखा हुआ है कि एनी मेटलिस्टिक पार्टिकल विल नॉट अचीव स्पीड ऑफ लाइट,
हाँ हाँ ये रखा है।
है ना। और अगर जैसे ही पार्टिकल स्पीड ऑफ लाइट को अचीव करती है वैसे ही वो मासलेस हो जाएगा। सो अगर पार्टिकल का कुछ रेस्ट मास है तो स्पीड ऑफ लाइट अचीव कर ही नहीं सकती है। दिस इज बेसिक एजम्पशन ऑफ आवर दिस क्लासिकल मैकेनिक्स, है ना।
Sir, it is only valid in STR domain,
Obviously, if you are
relativistic domain.
talking about the high speed range, if you are talking about the speed of light, then you are in the STR range.
सब तो क्लियर है सर।
है ना। सो
सर आपकी तबीयत भी प्रॉपर्ली ठीक हुई नहीं है।
हाँ हाँ ठीक है, अब चल रहा है, ठीक है, उतनी कोई प्रॉब्लम नहीं है, अब ठीक है ना। थोड़ी बहुत है, चला जाएगा। सो आई थिंक दिस इज द one of the most important theory we have to just understand. Try to think all these things, try to just remember all this formula, and we will try to solve a problem into next class. ठीक है, हम लोग कल की क्लास में डिफरेंट प्रॉब्लम सॉल्व करेंगे, ठीक है।
थैंक यू सर।
ओके
थैंक यू सर।
थैंक यू सर।